All right, I am back. And yeah, that's taken care of. I just wanted to finish up this sort of debug output. Maybe implement one more command just to show how it works, and then I will go for the day, and I will think of the next thing that we will do on stream. Um, okay, what was I working on? Oh yeah, I was drawing stuff. Moving to the next line. All right, now we're just gonna have to loop over. Let's see, 250. Wait, we're showing the move to the next line. Actually, I can just kind of do this without looping. So why don't I? So I'm gonna say, what do we have now? X. We'll do that in hex. And okay, so we're gonna say that. We're gonna do chip dot x. And I'm gonna give it like 1, 2, 3 spaces and a bar. I don't think we have a Y register yet, but we'll just put a space in there for it, and we'll put 0 for now. Let's take a look at what we got. We've got an accumulator. Let's actually see what this looks like real quick. Awesome, and actually you can see it changing there as you go, which is pretty neat, in fact. Pretty cool. Did that? So we're just going to do a couple more. We're going to do our program counter. We're going to put our flags on the next line, I believe would make sense. We're going to draw terminal. I think. Do this. Yeah, cross term makes all of this super easy. Most of this is just like typing it all out. So let's see what was on the next line. So we'll just do print flags. And then we'll do. Actually, we can make this a little nicer, I think. We'll do this with the one before here, so we'll just replace that with Z. So instead of just saying registers over and over again, we'll say register. X Y give that a couple spaces with a bar, and we'll let the program counter be on the same line for now. What doesn't I like about this? Ah, this is a bool. Yeah, so we can actually just have that print that way. Right, this wants chip X, chip dot Y, and chip dot PC. What doesn't it like about chip? Oh, right, chip 0. Let's take a look at that. We should be able to see the accumulator and program counter all moving, which is pretty cool, actually. All right, let's do memory. All right, so now we should move down 2 lines. Just do that in line, and then we'll print. I'm gonna move right. We're going to do that 16 wide and ooh. Yeah, plus we're going to change this at some point because we're going to need to see the individual memory mapped hardware. And we'll distinguish those. Yeah. Actually, we're going to give them separate labels. Eventually, we're going to have to break them down because it's really important, like, what each one of them is and what they do. So we're going to go through byte 1 to 128 here. So we're going to do that on... We're going to go 16 wide. I think that's good. And then 2, 3, let's see, 32, 64, 1, 2, 3, 4, and 8 deep. Yeah, so we're going to go row by row, and we're going to do by 8. So we're going to 4, 4i in, 2 to 8. That's in a command, right? So I need this to be outside of the command. Catch. Yeah, I have a habit of just saving, and then Rush Formatter messed everything up for me. So I need to actually type something in here. So what I'm going to do is Q. For J and 116. Q in here. What do we need to Q? So we're actually just going to literally write the bytes out. We've already moved. We'll move to the next line. And we're going to print the text representation. Put a space between them so it's not, so it's readable at all. And this is, we're going to queue print. This is format. And then we're going to do chip dot memory. And how is this going to work? If we're on row 1, it's going to be, it's not 1 to 16, it's going to be 0 to 16. For have to remember on the fly how to do this kind of sort of 2D indexing. If we're on the first row and the first column, it's 0 and 0. If we're on the first row, second column, so it's like plus 16. So it's going to be I times 16 plus j. And it's going to say, okay, it doesn't like that in the queue, so what we're going to do is we're going to get chip memory 16 plus j. We're probably going to need to turn all of that into a U size, right? So it doesn't like, this macro is kind of all messed up here. And we're going to do memory. Expected unit type found, result type. I'm not returning anything, so I'm not sure what's going on there. So if I, okay, so something, oh, standard. Do I not have all my match? So that matches the inner format, that matches print, this matches Q. Okay, so that works fine. So what we should see is a bunch of zeros on our screen. Let's see what that looks like. Hey, that I forgot to go to the new line at the end, but that looks about right. Everything's 0 currently, so you won't see anything changing. So after each loop, then we queue up a so move to next line. Okay. I messed something up. Cursor. Great. Okay, so then that should look a little better. Yeah, so you can see our X register changing over time, and setting all the memory, which is defaulted to 0. In fact, we could do something kind of fun and watch that memory be reassigned just for kicks and giggles. Where is it? In our main, we're setting up all this memory to 0. We actually don't need this much. Actually, let's go ahead and change that to while we're here. But we'll set it to 1 so we can watch it being overwritten. And this is 256. It's going to complain that that's the wrong size, but it's the right size. I have detected an error in my code, right? Because this should be setting everything from 0 to 156. So as that, interesting. It does set the first one, but there's something wrong with that offset happening there. So we'll have to do a little debugging. Maybe I'll do that today. And then, but we can actually just kind of copy all of this. So we're going to do RAM. Probably want a couple lines between that. So we'll do cursor move to next line. We'll do, I think we did 3 before. 2, we'll do 2 again. And then somehow I overwrote print, which is good. Okay, so there's the RAM. And this will be interesting because we'll have to offset all of them a little bit. Okay. I think that's actually about all we want to print out, so we're sort of done with that for now. So get status, get p. Yeah, this is adding cross term. With the message, and we'll say that we are print print chip and memory state. Go ahead and push that. All right, and let's see what's happening, and we can actually use this to debug. One thing I thought about is that you could like have an input required to go to the next one. For now, I'm just going to slow it down and see if I can figure out what's going on, because that loop is happening only so many times, and it should actually be happening 256 times. Let me actually show that real quick. Tic-tac-toe source. Tic-tac-toe.dasm. Right, so we are we're loading x into one or into we're loading 0 into x. We're loading 0 into a, which is the accumulator, and then we're storing a into a memory address that is starts with 0 and is offset by x, and we're increasing x. X should go through every value from 0 to 255 before looping back over to 0. And we should be seeing that, but that should take a lot longer than just the few seconds that we're doing. So I'm going to slow this down to 1 second. Take a look at what's happening to x. The accumulator should stay 0. I think it was changing. And x should count up. So you can see that A was counting up. Did I have the right thing printed out there? Let's take a look at our... That's the program counter, so that should be A. Okay. So A should stay 0, and X should start 1. FF. Okay, so that's clearly the problem. Is that X... I'm curious if it's not incrementing properly. So this is... So it doesn't look like it's happening in the inks. Okay, let's take a look at this. So we're loading 0 into x. Right, cool. So we hit the clear. There's 1 byte, 2 bytes, 3 bytes, 4 bytes, 5 bytes. We should be going back to here. Alright, so let's just start. So we're actually going to turn all this stuff off real quick. I'm going to do that about one more time and then find out a flag that I can use to... I think this is going to be a bunch of these aren't actually used. So where's clear terminal used? Okay, and so then we're going to just print. Instruction. So I think on each loop we're going to print the instruction as hex and x. Okay, here's what we got. All right, so we can take a look and see what happens. So, and we'll look at our. The first thing that happens is A2, which is load X, right? That makes sense. X will be 0 there. A9 loads A, which is also fine. X will still be 0. And then E8 increment, 95, stores A, so it stores in memory the value of chip.a, the, the index there is whatever the arg is, so that's in this case 0, and then, okay. And then D0, this is our next byte, right? E8, we incremented X. Okay, so this is that. And we set the program counter back to wonder if we have this backwards. Ah, right. Okay. I think we do have our logic backwards. So break not equal. So we're saying if it is 0, go back. But it would not be 0. So if chip not 0. So now we should see just a bunch more output. Yeah, as our X increments up. And then eventually we get an instruction we don't understand. Which I thought I was printing that out. Oh, sorry. Okay, so if we turn back on our debugs, yeah, so we'll need to keep that. We'll do all of this stuff. GC. It's going to happen 256 times, so I don't need to make that like 100 milliseconds so we can watch it. We're going to do this. Oop. Oh, man. Just really messed it up, didn't I? Okay, and then let's run that again and see what we get. You can see our program counter sort of looping around in A, or in our X register, updating, and we are setting zeros to everything. This might be a little bit slow, and I'm still printing this, which I should stop doing. But yeah, what you can see here happening is that sort of tight loop that we had going around and setting everything to 0. Normally we wouldn't see this because everything would be 0 initialized anyway, but yeah, apparently 100 milliseconds is a abysmal clock time, which totally makes sense. Let's see. Then it stops updating RAM. That's interesting. We'll deal with that a little bit later. So I'm going to go back up. I'm going to go turn off draw terminal. Okay, so we should get an error output when we're done. see if I have a print line sticking around somewhere. Okay. I think we're good. Let's make this like we can go 10 times that fast easily. So like why don't I go to there and we'll do it in the real terminal. So that's much better. Yeah, I think that was just a drawing glitch that kept those last two one because it was probably since it wasn't tall enough, it was overwriting the last line or two. So there, I think we actually saw what we expected, although I don't believe we got that ePrint line of what the next instruction is. So I'm gonna figure out how to do that. I think it just quit. So I think if we do a sleep before we tear down the terminal, we'll be able to see what the unimplemented thing is. We could also potentially panic it. We'll just do this and we'll sleep for a second before we tear down the terminal. But yeah, now we're seeing our registers update, our program counter update, and that did not take long enough. What happened? Broke that. It should sleep for a second. It did not. It also did not return my cursor. Let's see what happens here. Yeah, so it's just redrawing that one. That's weird. Okay. I might have to figure out some way to get that out of there. Actually, why don't we just... Oh, right, because we're drawing the terminal after it happens. No, we should be breaking out of the loop. Let's make sure I have all this set up properly. Yeah, this is surprising to me. Let me see what happens if I just go ahead and panic here. Panic. The disco. No DMCA, please. So it goes through all this. Did not panic. I think it's drawing over this last instruction so that the ePrint line isn't giving us what we want. So let's actually see what happens. Let's see what happens if we panic this. Get rid of that. Yeah, it says that's unreachable. Yeah, I don't really want to do that. Okay, actually, I know what to do. Tear down the terminal for now when we run out of instructions to run. Okay. And then panic. Unknown instruction. So then we should see the same thing happening again. Let's... I'm gonna make this loop like a little bit tighter even. It's gonna look kind of insane, but so one more time. Something is happening that is funky. It might be that this is not. Maybe it's. Now if I run it. Attempted to add with overflow. That's actually okay. So that's probably what was going on. So that's I do need a wrapping add for something that I got to earlier. I just didn't hit that case. Yeah, so I need to. Ah, that's cool. I need to figure out how when I'm showing all that stuff not to bury the message. I will see if I can figure that out. That's why I didn't return the terminal and all that stuff. Yeah, so I need to do chip.x wrapping add, and then wrapping add 1. All right, we got our unknown instruction. That is pretty cool. Yeah, so even though we don't have a torn down, so this should, yeah, even with the terminal up, let's make sure that that works. And then maybe either the option is to like make sure that things are printed anyway while this is going on, or the option is to have it easily able to turn off, like via something like a flag, which gets us into parsing options. But that is actually probably the best thing to do. But here you can see it filling up all the RAM with zeros, and then panicked at unknown instruction 9A, but it did return my normal terminal to normal. Let's make sure it did that in my normal terminal. Cool. Yeah, I have my cursor back. Awesome. So let's go ahead and recap what we did today. Today we we explained why I was having so much trouble with this sort of this relative offset. It was because I had forgotten my twos complement, and I sort of explained with a couple of examples how twos complement works and how it allows you to simply add a number even in its unsigned version and have the right thing happen because of overflows. I learned that wrapping add is important, that Rust panics at boundaries if you overflow or underflow a byte. I'm trying to think what else did we do, and then we set up cross term and uh, this handy dandy way of debugging our programs, looking at all the registers and the program counters and flags and how they're set. So that should be it for today. I have to figure out what we'll do next time. I may go through and implement some of the more boring, sort of repetitive tasks here, and then leave the next interesting problem for a stream. Eventually, we're going to have to figure out exactly how to get um, like a screen set up. We're going to have to figure out timing. Um, there's some stuff like where like down the road where we're going to interrupt the program flow and then restart it at a certain time. All of that should be super fun, and this is just one more step on the way to doing it. Cool. Until next time, I only have one viewer, so I'm not going to raid anybody with myself. I will see you later.